After today, you'll have all the types of stoichiometry that we'll talk about. We've done mass so far, mass stoichiometry, which involved N equals little m over big M. We did gas, which is PV equals nRT. And today we're going to do solution. Solution stoichiometry, this is unit 3 stuff. Remember, C equals N over V. Okay? N, of course, will be in moles. V is in liters, and C will of course be your molar concentration, moles per liter. Okay? So that's what we're going to use today to help us with some of this, and we can mix these together, by the way. Eventually you will have problems where we can take a mass and react it with, for example, so a solid, react it with a gas, and figure out perhaps what concentration we would get, or whatever the case might be. So we're eventually going to mix all these different stoichiometries together, mass, gas, and solution at some point. It's just a matter of knowing which formula to use when, kind of thing. All right. In this case here, we got a 3-gram piece of zinc. It's placed into some hydrochloric acid. And of course, we will get a single replacement reaction that looks something like that there. Okay, so zinc, hydrochloric acid, and gives us hydrogen gas and zinc chloride, aqueous solution. We need to balance it, so I think a 2 here will be just fine. We're going to do, as always, put the information in the right spot, of course. So we're going to take 3 grams of zinc. Let's do that. 3 grams of zinc is placed into a solution which has a 0.75 molar concentration of hydrochloric acid. So we'll use C here, 0.75 moles per liter. That's my molar concentration, moles per liter. That's C, of course. What minimum volume of acid, so what volume of acid do I need to use, how much acid do I need to use of that to react all the zinc? Okay? So in this case here, we are solely focused on the reactants here. We don't have to worry. We're not trying to figure out what the pressure of the gas is, although that would be a good question as well. So we could figure out, you know, eventually what's the pressure of the hydrogen or something like that if we wanted to. Okay? That could be, it's a slightly different question, but that could be a legitimate question. Or maybe we have to figure out the concentration of the zinc chloride at the end. In this one here, we want to just find out how much of that acid should we use to completely use up this 3 grams of zinc. Well, I know the molar mass here is 65.41 grams per mole, and I can find N from that. And N works out to be for there, let's see, 3 divided by 65.41 is 0.04586 moles. Okay? What we have to keep in mind is, basically what this question says to you is, hey, this is a 1-to-2 ratio right here, 1-to-2 ratio. For every mole of zinc that I have, I would need 2 moles of hydrochloric acid to use up that zinc, right? That would be a perfect reaction where there's no leftover excess, there's no leftover reactants, there's no excess, there's no limiting reactant. Basically, if I wanted to use, if I used 1 mole of zinc, I'd have to use 2 moles of hydrochloric acid to completely use that up. Okay? Well, I don't have a mole of zinc. I have 0.04586. And that 0.04586, of course, means that I'd have to use, well, twice as much of the hydrochloric acid here, or 0.0917 moles per moles. Okay? So now I have N and I have C, and of course I can find V. How much of that acid, what volume of acid should I use to completely dissolve this 3 grams of zinc here? Just a reminder here, if you're solving for V here, we need to do N over C, of course. Yes? So we're going to take that number here, unrounded of course, divided by 0.75. I'm going to get 0.122 liters, significant digits actually. By the way, 2 significant digits in this question. The 0 in the front doesn't count, remember, so basically 0.12 liters would be my final answer here. Okay? And that's how much volume of acid I would need to use. Do you guys remember in the lab we did that strip of magnesium? Remember? There was that in the test tubes. There was a strip of magnesium we put into hydrochloric acid, and it started to bubble. Yes, remember? Well, that's your bubbles here, right? And what happened to the magnesium after a while? Was it still there, or did it get entirely used up? It disappeared. Yes. So what happened was we put that magnesium strip into that, and it got all used up. Well, basically it changed into magnesium chloride, I guess it would have been. That magnesium strip disappeared. That's what we're doing here, and I'm not using any excess acid. I'm basically saying, hey, if I had a 3-gram chunk of zinc, if I put that into this concentration of acid, if I measured out 122 milliliters of that acid of this concentration, this would entirely get used up, this would entirely get used up, and I'd be left with just these two things here, basically entirely products. This is a perfect 1-to-2 relationship. If you looked at this after this reaction was done, there would be no excess reactant left over. There'd be no limiting reactant in this case, because it's working in a perfect 1-to-2 relationship. Okay? This is a 1-to-2, so is this a 1-to-2 perfectly. Okay? So theoretically, if I wanted to use up all the zinc and not have any zinc left over, or not have any hydrochloric acid left over, I would need to use 122 milliliters, or basically 0.122 liters, or 0.12 liters. Okay? And that would completely react, like I said, to give you both those products there. Yeah? All right. Let's look at the next one here. I'm going to get you guys to write out the equation for this, and I want you guys to put the information in the right spot, and actually I want you guys to do as much as you can here before I start as well. So go ahead and work on that one for a sec here. Okay, so once again, this is a pretty straightforward double replacement. I would expect you guys to be able to do this one. Okay, we got some ammonium sulfite. Ammonium sulfite. Shh, please. Hey. 1 plus 2 minus. So now that is aqueous. Okay, I'm not sure if that's on your periodic table there. Yeah, it is. So that one's aqueous. Ammonium tends to be very soluble, so the NH4 plus usually very soluble anyway. And iron 3 chloride. Okay, and once again, I would assume, I hope, that that one is also very soluble, so aqueous, aqueous. Double replacement reaction, metal's going to switch. I'm going to get some ammonium chloride, and some iron sulfite, iron 3 sulfite. Sorry. You need to look those. You need to look those two up. Okay, and this is very, very important, people, because if you get the wrong one, the molar mass is going to be different for both of those compounds. You're going to get the wrong answer, even though you've gone through the entire work. So you need to look both of these up to figure out which one is aqueous and which one the precipitate is, which happens to be this one here, the solid. Which one is slightly soluble, which one is very soluble. Because the precipitate is what you're trying to find, the mass of the precipitate, right? Predict the mass of the precipitate formed. Yes? So, a lab group combined 75 milliliters of 0.26 molar. Don't forget that should be in liters. Okay? With 100 milliliters of 0.18 moles per liter. Okay? So it looks like to me, once again, and then we need to figure out the mass of the precipitate. Well, it looks to me like we have information about both reactants here. So obviously we want to find those two. Let's find N here and N here. And it looks like to me we're going to have to compare these two to see if one runs out before the other one. Okay? So 0.26 and 0.075 is what? That's about 0.0195. Now don't forget, if we're going to compare these, we might as well do this right now. I'm going to take, oh sorry, I didn't balance it, did I? Let's see here. 6, 2, 3. Should work. Okay? Sorry, don't forget to balance it, of course. Otherwise, everything's a 1-to-1 ratio, and, well, that doesn't work out so well. So 0.0195 divided by 3. And we're going to get it down to basically a 1 here. Okay? So 0.0065 moles. Over here, I have 0.018 moles. And I'm going to divide this one by 2. And I'm going to get 0.009 moles. Okay? So what I've done is I've gotten both of those down to a 1-to-1 ratio. So this is my 1-to-1 ratio. If these were reacting in a 1-to-1, those would be the number of moles I'd have there for that there. Okay? For each one of those reactants. So which one's going to run out first, the 0.0065 or the 0.009? This sometimes gets confusing for you guys. Yep. Yep. So this one here, 0.006, is less than 0.009, yes? So this one, of course, the limiting reactant, put an LR up there, is going to determine how much product you can make, right? Limiting reactant always determines how much product you can make. And don't forget, this is for 1 down here. So this number is for 1. I need to get over to, let's see here, a 1, yes? So basically, I can just take that number and move it over, 0.0065, yes? So 0.0065 molar mass. What is the molar mass, somebody? It's 351.91 grams per mole. And if we multiply those two together, I think we get 2.287. 2.287 grams. Okay. Significant digits, of course, we'll have to discuss. So we look back in the question here. Well, remember, this is your limiting reactant here. So the limiting reactant, that's really the one we need to focus on because that's determining how much product we get. Yes? So we will look back at the original question. We have 2 significant digits. We had 2 there, actually 3 there, yes? 75.0 originally. So 3 and 2. So we have to have 2 in my answer, right? So 2.3 grams would be my final answer in this case. All right? Good? Questions, anyone? Yes, no? Good? So solution stoichiometry, of course, we'll use C equals N over V. Tomorrow we're going to talk about some titrations, which will be solution stoichiometry. Again, it's just a special type. And then on Thursday we'll go to the lab and do a titration as well. Okay? And we'll spend some time doing that. Let's see here. Tomorrow we're going to have a quick little quiz here. Probably, honestly, and I'm just going to be pretty general here. It's going to be on stoichiometry. It's going to be 2 questions, okay? The first one is probably going to be just like moving N around, very basic type of stoichiometry question. So I might give you the mass of the reactant and ask you how much product you'd get or how much product you'd expect to get. And then question 2 is going to be, well, here, I'll give you here. Question 1 would be something maybe like this, although I probably wouldn't give you this one tomorrow. I might give you 3 grams of zinc and ask you, for example, what pressure of hydrogen gas would you expect to see if I gave you the volume and the temperature and all that other stuff, like kind of like what we did yesterday. Okay, so I'd give you one of those, and then I will give you something similar to this where you have to compare the 2 numbers. So you will actually have to do the limiting reactant part and compare them and see which one's going to run out first and then predict based on that. Okay, and I think only 2 questions for tomorrow. Okay, so we will have a quick little quiz on that tomorrow. I guess we should pick a day for your Unit 4 test as well here. We're probably going to be, we'll be done, well, Friday easily for sure, but probably even Thursday with this stuff here. Thursday is basically, or actually technically tomorrow we're probably done this unit. But I think we'll give you the test on Wednesday of next week. And that'll give us Thursday to go over it as always. Okay. And we'll have a little time to go over it there and stuff like that. Okay. And then talk a little bit about final stuff, etc., etc. Okay.